Hi, my name is Philip, co-founder of Crodox. Crodox is a slicing software that analyzes codebases and identifies subcomponents, along with their dependency structure. These subcomponents can be automatically extracted into independent workbench repositories, allowing developers to work on individual components without the distraction of the much larger main project. And once changes have been implemented, Crodox automatically applies them back to the main project. This workflow has several key advantages, including improved security, faster onboarding, reduced context, and better control in AI applications, while giving users the freedom to customize and design their own workflows to fit existing processes. You do not have to change your architecture, and you do not have to use it for everything, because it works through regular Git commands. Crodox is a deterministic software and does not use AI for the slicing itself. However, the slicing can be used as a pre-processing step for AI requests. Hi, my name is Philip, and today I would like to demonstrate how to sign up to Crodox and how to link your existing GitHub account with Crodox in order to analyze code bases. So all you basically have to do is go onto the website crodox-app.com, and there you can just type in any email address, agree terms of service and privacy policy, as well as confirming that you are 16 and above. And then just request a verification code, which will be sent to the email specified above. Now I received my verification code. I just type that in, click verify code, and I land on the home screen. But we already see that we are not connected to any GitHub account. So in order to do that, we only just go to settings, and we see we have no account in connection with the Crodox account so far. So all we have to do is install a GitHub app in our according GitHub account. For this, we click on install GitHub. For this, we now have to sign up with the GitHub account we are using. Sign in and install the GitHub app. Now we are back in our settings and we see that we have connected to the GitHub account. If this isn't showing up straight away, you might just want to click relink to GitHub. This sometimes is required. However, if we now go into repositories, we see that it has successfully linked to our existing GitHub account and shows all the repositories, in our case just the single one, that are in the according GitHub account. Hi, my name is Philip, and today I would like to demonstrate you how to import existing templates into your Crodox account. For this, you already need to have a connection to your GitHub account set up, but once you have done this, you simply go to Crodox-app, and then you can find the Angular template, which you simply have to fork to your own account. Create a fork. And once that's done, we will just see that this shows up in our account. We just refresh and we see we have the fork for the Angular temp right here. And the same should be happening in your Crodox. Once you refresh, we see we have the Angular temp now listed here as well. So all we now have to do is create a new template. Obviously there is no template there already, so we go in our demo, create, and this creates just an empty template. So for this, we want to fill this one with the one we just forked. Yeah. So for this, we select the import template from repository and select Angular template import. And now it's just loading all the specifications from the repository we just forked. And here are all the specifications, and now in the next video we will have a look at how we actually use this kind of template to analyze code bases. Hi, my name is Philip, and in this video I want to demonstrate how to use Crodox in order to analyze and extract subcomponents from your code base using Crodox. In order for this to work, you have to have the connection set up between your Crodox and your GitHub account. and you have to have a functioning template that works on your code base. In our case, we have done these steps already in previous videos, so check them out if you have any questions. And starting from that point, we are planning to work on this repository, and I have set this up so that it is already running. So this is how it actually looks like. This is a CRM project of a decent size, and you can have multiple views. And we are, in our example now, interested in extracting the dashboard component into an independent environment so that we can work on it on a reduced context and make changes and reintegrate them into the main project. So basically we start by just creating a workbench, selecting the template we want to apply. In our case, it's the Angular demo template, and the project is already set up, in our case, the material dashboard Angular 2. Now we just use the file tree to look for the component we are interested in our case, the dashboard component, and just select the dashboard component file. We can have a more detailed look into the structure by just clicking the file, and now we see the object tree that is created based on the syntax that is defined in the template, and we see also the components that are actually inside the source file. So if we unselect, for example, the template UI, we see that this is connected to the HTML file because it's referenced here. So every time you unselect this component, basically you also no longer are needing the HTML file. However, there is a dependency flag here so that the Crodox is actually recommending that you keep this inside because it is something you are actually relying on. So we go ahead and recheck this box. And all we have to do now is basically give it a name. In our case, we just say workbench. Lowercase letters, and now we can just create a workbench. We see a counter up there where it actually shows the loading process. And once that is completed, a repository has been created in your GitHub account, as well as a branch on the Material Dashboard Angular 2 project, where the final changes will be committed to. So we just follow the link here, and we are now inside the newly created workbench. And if we go into our GitHub, we now see that we have a new repository which is called Workbench. Similarly, we also now created a new branch inside Material Dashboard Angular 2, which has the same name, just with a Crodox underscore in front of it, basically. So we could now use basically just the repository created here, and you could use any IDE you are familiar with. However, in this demonstration, we just used the shortcut to codebase in order to make our changes and commit them back to the project. So this will take a while, and once this is loaded, we come back and apply some changes. Now our workbench is fully set up. I run an npm install as well as started the application. So now we can have a look at the structure. So if we go into app, we see that we have the dashboard component now lying inside this environment. And once we go in here, we see the environment we pasted the component into, and here it is actually referenced. And once we click that, we actually see that the component is now running inside this new environment, completely independent of the original project. And here we can now apply any changes we would like and reintegrate them back into the main project. So now Copilot is finished applying its changes, and we see that all the background colors are now green, and we would like to keep this and we want to apply it to our main project. So in this case, we just work like usual. We are committing our changes. Like so. Synchronize, and once we do that, we can switch back to Crodox, where these changes then are detected. So all you have to do is basically just load merge preview. And we see one file has been changed. And if we look into it, we see that the CSS has been changed. And to apply this to our main project, all we have to do is to merge to origin. Yes. And now the repository workbench will be deleted and the changes will be applied to the branch we have seen earlier in GitHub. We see there has been a change made to this workbench, and we can look at the commit basically and see these are the changes we just made. So now we can build the main project again and see how it actually looks like. Here we see that the changes have been successfully applied to the main project while the other views haven't been touched. And this basically presents the workflow Crodox is intended to be used for. Hi, my name is Philip, and in this video I would like to demonstrate how to use Crodox in order to design and to create your own templates. This is a more advanced topic, however, it gives the user quite a powerful tool in order to design their own workflows, and it offers quite a bit of customization options. So for the purpose of this demonstration, I already created a simple pseudocode example repository, which is available at Crodox-app called Simple Demo. And it just includes basic functionalities of programming languages, just to show the basic structure of the templates. So I already went ahead and forked this repository into my GitHub account, and this is why it's showing up here already. And what we do have to do now is just go into templates and create a new template by simply typing in the name and click the create button. The template then is generated immediately, however, it is obviously empty at this stage. So now starting from that point, what we now start up with is defining the file itself. So in our case, we are looking at txt files since it's just pseudocode. This is something we can easily define like so. So it is basically a query language we are looking at here. So we just define the name. I just call this always from. And here we actually define the ending of the file we are interested in. So every object defined within this body is applied to all the files with a txt ending. And if we save this, nothing is going to happen because we haven't defined any objects yet. So we go ahead and just start by applying our first object. So the syntax for this is looks like so. And for example, if we would now like to get this class as an object, we just call it class. And what we basically do is we can start off by just copy and pasting how the syntax should look like. And if we save this, we can now have a look here and see that we actually were able to extract this object. However, this class is just defined as this part of token. And if we go into another file, basically, we will not recognize this class because here it's actually called C2 and not C3. So we go ahead and just change this around because Crodox allows us to define variables as well. And if we call this name here, now it expects a class token, also a token called class. And behind that, it expects a variable and then to one opening and one closing bracket. And if we save that, now we are actually successfully able to identify this class. Similarly to the other one where we still identify this class as well. And if we go down here in the extracted components list, we actually see two classes selected, and they have a name variable basically, and one is called C2 and the other one is called C3. This is basically how this works. So if this actually correlates to this naming, so if it, for example, we call this name2 and save, select this object again, we will see that the naming has changed. So this is a real-time reference point basically. So next up, we actually we were just able to identify the start of the class basically, but what if we want to extract the body as well? This can be easily done by simply defining the braces, and inside those braces there can be any type of other objects. We have no objects so far, but in the future we're going to have some. So we declare this as a sub-body, and once we save this, it basically accepts any type of input inside that class, and once it comes across a closing bracket, it will stop at that point. So if we select the class here now, we actually see it selects everything. However, it will run into problems whenever we see something like this, where actually another element has a closing bracket. So in this case, it's always the simplest solution just to define the brackets themselves. This makes life a lot easier because then the structure will always be remained. So here we see already how these sub-bodies actually function. So now these brackets are inside the class structure. However, we don't have just brackets here, we actually have functions. So we go ahead and just define another object. In our case, we're just gonna call these function. However, if we save this, nothing is going to happen. We can go ahead and we will see that it's still brackets because inside those braces there is actually some variables inside. So we can actually define those two by a simple structure like variable name, and we can actually create loop structures as well. Their syntax basically goes like so, and here we define a comma and another variable as well. So what we actually define here is we actually expect a variable, and then we expect a loop. This can be 0 or 1000 basically, where a comma and then a variable follows. So if we go ahead and save this, we see that the function is now declared, and we will also see that these variables will show up in the list of names in the components. So if we look into the functions, we will now see we have name2 because this is called name2, and in these names, for example, we have all the variables inside referring to these ones. So next we actually saw that I just selected one function. However, it selected the other function and the class as well. This is a default behavior in subcomponents. So basically, whenever I drop a subcomponent, Crodox assumes that the child is dependent on the parent and the parent is dependent on the child. The child will always be dependent on the parent. However, there are some cases where the parent is not dependent on the children. And this can be easily defined by simply referencing the object name in the subbody, right? So, and what we now will see, the behavior now will change in the case that whenever I select a class, for example, it will not automatically select the functions. Or in a different scenario where I select a single function, it will select the class but not the sibling function, basically. So from this behavior we actually see that we are able to extract just the parts of the code we actually are interested in. And these are the objects that are actually drawn up from these queries. Next up, we might want to have a look at the variables, for example. In this case, we have a few variables inside those functions, and we can simply define them in a way like so, where we say variable, and they are actually structured. We go ahead and do it the proper way from straight away. So they are basically structured like this. So we go ahead and replace them with variables, because and a variable here as well. So what we will now expect to happen, it will, whenever there's a let and a variable inside, then it will just detect them. So these ones will not be detected. However, these ones we would expect to actually be detected. And so we go ahead and see if that actually works. So inside those functions, we actually have subchildren. And in this case, it actually detects, this one actually refers to this variable. If we now would like to detect these variables as well, there's a different syntax we can use. And this is basically an OR statement. So whenever we declare something like this, we have basically two bodies. And one body will, it basically decides which part, so both of these parts can actually happen. So in this case, nothing can actually be there, or when there is an equal sign, it will go down this route and will expect a variable and a semicolon at the end. If we go ahead and save this, we will now check whether or not we are now seeing all of these variables as well. And we see this is actually how it works. So they're actually working. So now that we have defined the rudimentary syntax of this pseudocode example, we now can have a quick overview of the dependency structure. Crodox is quite powerful in that regard, that you can draw up dependencies between these objects. And the way this works is basically by grouping these variables together into a same group. So whenever they have the same name and the same value inside. So for example, in this case, this value DDD has the same group name. In this case, it's simply just name as this one. However, in the normal programming sense, they are actually not related, since they are defining a completely new variable. So this is something we can actually display in our syntax here as well by simply making this uppercase. So if we call this name, we now define that this variable starts from new every time. This is something we also want to do on the function in this case as well, and on the class as well, because they are always defining a new object, something that's not referenced to. In a similar way, in this case, DDD is referenced. So whenever we now reference this again, we don't want to draw up a connection between this and another reference. So there is another syntax like so, where we actually say, okay, now this is a reference of another variable basically, and there is no connection between those in between. So there are a lot of varieties which you can actually look up on the wiki in more detail, but just as a quick overview. So now how would this actually look like in our example? So we extend the language to actually take variables as exceptions as well, because otherwise variables would be always be picked. And we also have a little bug here. We just put that over there. This is more correct. So if we save now and look and just select the class, we see that variables are not selected by default. But if we go ahead and select this function, for example, only the function is selected. However, if we select this one, we actually see that these variables come alongside, because they are correctly referenced. Even though these share the same name, they are actually not, there's no connection between them. We can see this in more detail if we go into a single variable, and we see that this line actually referenced to this variable line up there, and similarly in this case as well. This is just a very basic overview of how these dependency structures work. Again, you can look these up in more detail on the wiki page for all these special cases. There's one more example I would like to demonstrate here, and this is something to do with import statements. So if we now look for a file that actually has some imports, like in this case we have an import, and there is a path associated with this import. So we go ahead like before and just define import. This is something we just do with the syntax like so. And again, we would just recognize this one and not the lower import. So we just go ahead and make the necessary changes in this case. And now we have a special case. In this case, we actually have a path. And this is something in Crodox you can actually define as well. And this is defined like so. So you just define from, and this from actually refers to this from, which is actually the path name. So whenever they match up, they draw up a connection, and if they find something like a class name, for example, then they draw up a connection. However, this class name wouldn't be recognized because it is on a lower level. But we can do this as well by just declaring this up. So we now push up the class name into the level of the file name. And whenever now something like C2 is referenced, it is pushed up to this path and the connection is established. So, but what we are left to do is the ending is actually cut off. So this is something we have to reflect here as well. So now we actually see we have both imports set up. It doesn't recognize the class. This is because this is still empty. We will just take this statement up here as well. But we have seen this can be empty as well, so we can go ahead and make this a little bit more correct, like so. So we just go in a loop, except a comma or any type of variable, basically. So these are variables, they're newly declared as well, so they're uppercase variables. And if we take this out now, then we have declared this correctly, so we should actually see the class now. Yeah, and we do that. And now once we select an import statement, what we would now expect is that the according file is selected as well, because we are just drawing up a connection to them. So we go ahead and see that we actually drew up a connection between bridge test 2, which is right here. Now we go ahead, take the other import, see what happens. Nothing is actually happening, so we go inside and we see this is actually a function. So we did the upper passing just for the class, so we apply this to the function as well. We also see it's not recognized as a function because it's an empty bracket. This is something we just did for the class, so we're just going to copy this statement here. And now it will actually accept an empty state as well. See again, yeah, we now recognize the function, go back to this view, and now if we select the import, we actually see that it actually follows the folder structure as well. So this is meant as a quick introduction into the core functionalities of Crodox. So there's a little bit more to it, but you can read any details up on the wiki. So if you have further questions, please check that out. And from that point, now I would like to move ahead and show the rest of the template features. We had already a quick look into the extracted components. This is basically just a list of all the objects we have identified using this syntax. So when we already have seen that the naming, for example, refers to the object types. So next up, we're going to have a look at the patchmaker. This is actually quite a powerful tool where you can place specific integration patches into any repository you define in your GitHub account. So now I just created a simple temp example in my GitHub account. It basically just includes a README file, but this is enough for our purposes right now. So what we can do is open the patchmaker file, and we don't actually need that for the moment. So we can now select the simple temp as the source for the changes. And now we can construct something, basically a decision tree structure based on the object we extracted up there. So for example, if we go ahead and say if title for example, function. So whenever this is true, we can now create a specific modification in any file of the simple temp repository. So we can go ahead and just try, for example, we add a mod and we just have the README. So this is something, this is the first one selected, and we just go ahead and name this mod 1, basically. So once that is done, we actually see this refers to the README file. This is actually the same inside than here, and we now can modify this whenever we come across an object. So for example, if we type in here hello function, so every time we are now referring to a function, we actually create a patch that creates this hello function phrase. Yeah. So in our case, we just selected one function. However, we could actually come into the situation where we actually select multiple functions, like so. And we see that the patch immediately responds to that. We can also create dynamic mods where we basically just refer to specific values inside these objects. And there the syntax goes like this again, and we just refer to name, for example. So this would be actually referring to this name. And since they are always stored in a list, we have to say name 0. And now we actually see that hello function F5 and F1, and they refer to the objects inside here. This one would be F5, for example. Now that we had a look at the rudimentary components of a template, we now can just have a look how this actually affects the workbench creation. So for this, we go on to create workbench, give it a name, workbench test, for example, bench. Select a template, our syntax demo in this case. We see the preview of the syntax we just defined, and we just go into any file, select function. So we would expect now to just extract the F3 function as well as the C2 class, and we also can have a look at the patch we just created, so hello function F3, which would be in the README file. Go ahead and create. And once that's created, we would expect in our GitHub account to have a new workbench repository set up. So this is created correctly. So if we go on to the branches, we see there is a Crodox workbench test branch on our simple demo repository. If we go into repositories, we see there is a workbench test, and inside here we have one bridge test 2, which only includes the F3 function as well as the class. There is obviously a spacing problem, but this is because it is just a rudimentary example. Same with the README file, we see there is the patch also applied to the README. So this is basically how the workflow works. We could now apply any changes we would like and reintegrate them back onto our main project.